Hi everyone, this is second video in this series, data structured and algorithms. First video we are talk about introduction to data structured and algorithms. So I think you all have a good idea about data structured and algorithms. So today we are going to implement list stack. List stack means stack implement using list. There are two kind of list, array list and linked list. So this implementation part I selected linked list. So first of all we have to know what is stack, what is linked list, and what are the stack operations, like that things. Okay, let's move to the stack. First of all, what is stack? Stack is a linear data structure that supports LIFO operations. LIFO means last in, first out. I'll give some small example. Imagine a stack of plates. We always choose the plate on the top, not the plate on the bottom. Stack is like that. When the place in the plate, the last plate, it means last place plate always come to the top. So we are take the top of the plate. So I think now you have simple idea about stack. Let's move to the stack operations. There are some stack operations like push operation, pop operation, peek operation, and isEmpty operations. Let's see one by one operations how does work. First, look at the push operation. We always use push operation to put an element onto the stack. You can see an animation how does push operation works. Do you remember example of plate took earlier? Here as there. We pushed element to the stack. There comes to top of the stack. Do you remember LIFO principle? LIFO principles works there. Now let's look at the pop operation. This operation wants to us remove an element from the stack. See the animation. It shows how does work pop operation. The last element added to the stack is removed by pop operation. Remember LIFO principle, last in, first out. Okay, now we are discuss the main operations of the stack, pop and push. There are some common two operations, isEmpty and peek operation. We all have some small or knowledge about programming subjects. So the isEmpty operation check the stack is empty or not. Let's move to the linked list part. First of all, what is linked list? Data structure for sorting object in linear order. Each object has data and pointer to the next object. Linked list is similar to array, but it's not array. Linked list divided into three parts: singly linked list, doubly linked list, and circular linked list. Look at single linked list. Single linked list works only forward, not a backward. Double linked list can on forward and backward both. Double linked list can transfer forward data and backwards. Now look at the circular linked list. The last node connect to the first node. You can start at any node, eventually return to the starting node. I select single linked list. So we know what is stack, what is linked list. So now we can implement list stack. So move to the code implementation about list stack. Okay, look at the code. First of all, I create a new Java project stack using links list. I'll create the Java project to implement stack using linked list. Then after I create another package stack linked list code. Then after I create again Java class, not Java class. So this Java class I create two operations that we all know Java. We have to create this getters and setters class. Then I will explain line by line. You can easily understand this code because I using comments. And first line, public class not class. Declaration for public class name not class. This means I create a public class. I said earlier I'll create a new Java class. Its name is not class, and you know private int data. This is a variable to a private type variable to field to store integer type value. So I'll create that variable to store some values, integer type values. This variable work as a linked list node. Private node class next. This is another variable. This node class, the private type variable. This variable helps to store the next class reference. You all know linked list have not then reference. The reference part have the next processing not reference. I think can you understand? And next line, public not class in data. This parameterized method, it's a constructor to initialize nodes class with data. Okay, can you see that comment? Public constructor to accept an integer values as a parameter. This data equal data, this dot next equal null, this dot data equal data. Assign the provided data not class to the field. And next line, this data equal null. This next equal null. It means initialize to the next reference to the null since the new node. I said earlier the linked list have not then reference. The reference part is null. There isn't next processing node. Okay, that code part says that. Then after getters and setters, you all know getters and setters. Are you learning data structure and algorithms? I think you have getters and setters coding background. Public in get data. This getter create to get values from the data variable and return data. Public void set data, that gathered data we initialize to data variable. This is setters. like as not class. This is also getter, and this is a setter. This is also setter. And these methods we creates to show the output. So customize an string representation of the node. It means how stack works, that we have to look at the output now. These methods create to for this. So this node class I explain. If you want to know greater than this, you can read that comments. The comments that comments have all the things, all the explanation line by line. So let's move to the stack linked list. I create another Java class, this one. Its name is stack linked list.java. So first of all, we have to import this Java package. This name is Java util empty stack exception. It's help to use is empty function. We can't use is empty function without that empty stack exception library file. Okay, public class stack linked list. This is I'll created that Java class. So this is a variable private int length. So can you see, the field track the number of elements in the stack. This variables helps to track how many elements in the stack, and it represent current stack elements. So and another variable not class top. This field holds the reference of the top node in the stack. This variables helps to gather top node of the stack. I already said LIFO principle, you remember, always pop last in element. So that node class top variable helps to gather that top elements reference. So and I'll create a method. Can you see, public stack linked list. It's a constructor to initialize an empty stack. First of all, we have to initialize empty stack. So length equals 0. It means stack didn't have any element. So initialize stack length 0 since it's empty. Okay, can you understand? Top equal null. The any element didn't have stack, so there isn't any top element. So the top element is null. And I create a push method. I will remember push method to put on the elements on the stack. We using push method. This is push methods code. And I create public non-returnable type push methods using parameters. And can you see the method add to element push operation into the stack? This line. Create a new node constraining the given data. So new node dot set top. Link the new node to current top node in the stack. Top equal new node. You remember we are put on the element in the stack, the top is last in one, so this do its. Then after I will push some elements to the stack, the length is up in one, this line it's do increment the length to reflect to additional new element. This is isEmpty function. Can you remember isEmpty function? I told earlier. This method check stack is empty. Length equal 0. This is a Boolean type operation. Return true. Length equals 0 and the element in the stack. When we call that method in our code, we can see our stack is empty or not. This is pop operation. Pop operation means remove element from the stack. I told earlier. Can you see? First check the stack is empty. This is this function we are earlier created. Can you see? Check if the stack is empty before attempt the popped. It means when we pop the element, earlier check stack is empty or not. When the stack is empty, we didn't have any elements to pop. Is empty, throw new empty stack exception. So throw an exception to indicate that stack is empty. Deadline in data equal top dot get data. It means retrieve the data of the top of node. I told earlier it's get top of the element in the stack. Top equal dot get next. It means update the top to reference to the next node into the stack. Return data. When we push some elements, we have to decrement the stack size. So this code line do that. Decrement the length to reflect to removal of an element. Return data. Return the data from removal node. These methods I'll create to check size. It's check the array stack size, how many elements in there, such that things. This method I will create to override to the string methods to provide string description of the stack. And you see this line, use string builder for the efficient using string construction. Not class current equal top. So look at this, start travels from the top of the stack. Always stack works in the top. Okay. So this code part is over. You can read I tell earlier, you can read that comments. I will explain that using that comments line by line. Now we have to create main method. Without main method we can't run this program. So I'll get a new like as that, right click and go there, new main class, and this is it. So this is main method. This is constructor, stack linked list equal new stack linked list. So these are the we already created operations. You remember stack dot push 10. It means stack dot push. Stack dot push means we are push the 20 integer put on the stack. These three steps are like that: 10 pushed, 20 pushed, and 30 pushed. After we can see, okay, I will run and show you. Can you see? First line, system out dot println stack dot to string. It means I'll explain earlier that method. It means how stack works. It's represent to user. Then we are push 3 elements to the stack, 10, 20 and 30. Now you can see that's 10. First we pushed 10. So you can see, first we push 10, second we push 20, third we push 30. So can you see the first pushed element is lower element in this stack. Can you see? The last push the element in the top of the stack. So this is the method, first in last out. This is the stack. So second one is system.println stack dot is empty. I saw earlier these methods we used to check the stack is empty or not. It's a can you see? It's not empty, fails. Third element, third one, system out dot println stack size. So can you say this stack size is 3? It means the stack has 3 elements. Now we do another operations. So stack dot pop. I said earlier that 3 operations, and that these are I created methods to, and I explained earlier. Now I call that pop operation. So and after have run. So can you see? We put on the stack lastly 30. That's remove element is 30. Can you see? That is stack implementation. So I think this stack implementation is over. So end of this session we know what is the stack, what is linked list, and how we implement list stack using stack and linked list. So we are learned a lot of things. Then we will meet again next video. Then bye bye.